Hi class, welcome to the next section, chapter 4.4. We're going to move on to the derivatives of the next type of functions. So we've covered polynomials, we've covered exponentials, and now we're going to cover trig functions. So in between those two, these three, I guess you could say, we covered the product rule and the quotient rule. So we now have enough information to do the next type of functions, which are trig functions, where we will end up using some of the quotient rule in order to derive some of the formulas that we're going to use for these. Okay, so in order to get our derivatives for cosine and sine, instead of like the last few times where we're using the limit definitions, we are going to go ahead and we're going to just analyze the graphs. Okay, so we're going to use the graph of cosine. Okay, so if you remember at the beginning, I said it's very important that you memorize what the graph of cosine and sine look like. Anything else that you do for trig will come off of those graphs, right? Or at least know their values from the unit circle. And anything else trig related you can figure out as far as triangles and circles and their values and things like that. Okay. So for cosine, we know that we have a period of 2 pi. So if we start at 0, we hit our next peak at 2 pi. So halfway is pi, halfway between that is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. We know we have a max value of 1 and a min value of -1, things like that. But as you can see, I don't label any of those values on a graph because yeah, they're important when we're talking about trig stuff, but we're really focused on derivatives right now. Okay, and so what we're going to do is we're going to use the fact that the tangent line of a function is 0 when the tangent line is flat. Okay, so if I look at all the times when my tangent line will be a horizontal line, that'll be at the top, the maximum values, and these minimum values, right? So at this point, my tangent line has a slope of 0. At this point, my tangent line has a slope of 0. And at this point, my tangent line has a slope of 0. And so forth, because remember, cosine goes on forever and ever. So if I'm looking at the derivative function, when I'm at an input of 0, my tangent function, my derivative function should have an output of 0, because that's the slope of the tangent line. When I'm at a value of pi, my derivative function should have an output of 0. When I'm at 2 pi, my output of my derivative should be 0 because that's the slope of my tangent line. So if we just kind of look at those, so we'll draw another graph right below our cosine graph. So at this point, my derivative function should be 0. At this point, my derivative function should be 0. And at this point, my derivative function should be 0. So 1, 0 is here at my starting value. At pi, I should have an output of 0. And at 2 pi, I should also have an output of 0. So we actually have a function that does that. Okay, and that's this function. So here, if I drew a tangent line, I would have a negative value. So that means that my derivative function should be negative because I have a negative slope, right? This is a positive slope. So from here to here, my function is increasing. So from that point to that point, my derivative function should also be increasing. It should be positive. And so this graph is actually a sine function because it starts at 0 and it ends at 0 over one period. But instead of going up and then coming down, it's going down and back up. So this is actually negative sine. Okay, the derivative of cosine is negative sine. Right. So the derivative of cosine is negative sine. Now we can do the exact same thing to figure out what the second derivative would be, but I'll just tell you what's going to happen. So if we do the same thing for sine, my derivative will be the cosine function. So sine and cosine are related by derivatives, right? So the way that I remember these things, if I take multiple derivatives, okay, is that my cosines, when I take their derivative, they change sign. My sines, when I take their derivative, stay the same. C for change signs, S for stays the same sign. Right? That's how I remember it. It always goes cosine to sine. sine and cosine. So it alternates between cosine, sine, cosine, sine, cosine, sine, cosine, sine. But what's hard to remember is, when does the sign change? So cosine, C, I change signs. Sine, S, stays the same. That's how I remember. That's me personally. That's how I do that. So here I just writing that for you guys. Starts with a C, it means it changes a sign. Sine starts with an S, which means it stays the same. Okay. So if I go in order, if I keep going, if I start with cosine like we did before, the derivative of cosine, right, will be a sine value, and it's going to change signs, so it's going to be negative sine. The derivative of sine will be a cosine, but it stays the same sign. So if it's already negative, it stays negative. Okay. The third derivative of cosine means that I take this derivative and it'll change sign, so it goes to sine and it changes from a negative to a positive. Okay. If I take the derivative of sine, then I will get a cosine function and the signs stay the same. Right? And then look, I'm right back where I started at, back to cosine. So my fifth derivative would be this, my sixth derivative would be this, my seventh derivative, and then my eighth derivative. It's cyclic. It's cyclic in nature. Every time I take 4 derivatives of cosine, I end up back at cosine. Okay. So this would be first my function, first derivative, second, third, fourth derivative. And then if I want to take the fifth derivative, I'm starting from here. So this would be the fifth derivative, sixth derivative, seventh derivative, eighth derivative. And I'm back at cosine, so then I would go back again if I need to do the ninth derivative, and so forth and so forth. So it goes in cycles because I always end up back at cosine. Same thing if I started with sine and then I started doing my derivatives, I'll end up back at sine at some point because it just alternates back and forth between sine and cosine, and the signs will also alternate according to whether or not you're taking a derivative of a cosine function or a sine function. Okay, so the cycle repeats for 5th, 6th, and 7th values. So again, this is called a cyclic nature for our derivatives. So now that we understand the way the derivatives for sine and cosine work, and we know how to do the quotient function, we can find the derivative for tangent, because tangent is sine over cosine. Okay, sine over cosine, I know what these derivatives are, and I know how to do the quotient rule. So the way that we derive the derivative for tan is by turning it into sines and cosines. So just like in regular trigonometry, whenever you kind of run into problems with stuff, you just turn everything into sines and cosines and simplify as much as you can. That's generally a valid approach at most points in trigonometry. Okay, so same thing, if I want to find the derivative of tangent, I am going to turn it into sines and cosines and take its derivative, which means I have to use the the quotient rule. So I'm going to take the derivative of sine, which is going to turn into cosine, and I'm going to leave the second function alone. So in the numerator, I'll get cosine, cosine. I'm going to subtract from that, sine being left alone, and then the derivative of cosine, which is negative sine. And then the denominator gets squared, so I get cosine squared on the bottom. So this is nice because in the numerator, I'll get cosine squared plus sine squared over cosine squared. Right? You might remember that cosine squared plus sine squared is 1, so this is actually 1 over cosine squared. Okay? And if you remember what 1 over cosine is secant, so 1 over cosine squared is secant squared. So the derivative of tangent is secant squared. Okay, so now we'll go over cotangent. We're going to do this in exactly the same way. If tangent is sine over cosine, that means cotangent is cosine over sine. We're going to do the exact same thing. We're going to use the quotient rule. So maybe you want to pause it real quick and try it on your own and see if you come out with the same thing that I'm going to come out in just a second. Okay, that pause is for you to pause it, so hopefully you did, and you come back and you've already derived this. So we're going to do the quotient rule again. So the derivative of cosine, so that'll be a negative sine times sine minus cosine times cosine over sine squared. Okay, so this gets derivative, so it's a negative sine times the bottom function, then subtracted by this numerator value function times the derivative of sine, which stays the same, so it's just cosine. And then we have sine squared on the bottom. So this is a negative sine squared minus cosine squared. Okay. So here you see I pulled out this negative. There should be another parentheses on here because I pulled out a -1. The negative sign from both sides, so I'll make sure I put this extra parentheses on this side. So this gives me a -1 over sine squared, okay, which is the same as negative cosecant squared. So the derivative of cotangent is negative cosecant squared. So if I want to do the derivative of secant, it's the same thing. I'm going to turn this in terms of sines and cosines. So that's going to be 1 over cosine. Same thing, do the quotient rule. Okay, so it's going to be the derivative of 1, which is 0. It's not just that it goes away, it actually goes to 0. So it'll be 0 times cosine. So the first part will have nothing. And then I'll subtract from that 1 times the derivative of cosine, which is negative sine. So I will have a positive sine over cosine squared. Okay. So the two negatives means that this sine will be positive over cosine squared. This is okay as an answer, but it's not super useful for us when we do math. So we're going to separate this, okay, into a tangent times a 1 over cosine, or tangent times secant. Okay. So here I chose to write it as sine over secant squared, but the standard is secant times tangent. So this first one is okay. It can come in useful, but in pretty much every textbook you're ever going to use, when they take the derivative of secant, you will see secant times tangent. This is the one that they use. Okay, so they pull out 1 over cosine, and you're left with that sine over cosine for the tangent, and then the 1 over cosine is your secant. So this is the simplified form that we generally will use for this. Okay. Same thing for cosecant. We're going to break this down to the derivative of 1 over sine. Do the quotient rule, it'll be the same thing. The first part will go to 0, and we will have minus. It won't be a negative, it'll be a positive cosine because this is sine, right? So the derivative of sine is cosine. So I will have negative cosine, over sine squared. Okay, negative cosine over sine squared. So when I simplify this, we can write it as cotangent, right? Negative cotangent times 1 over sine, so cosecant. Negative cotangent times cosecant. There's a secondary form we can write for this, but this again is generally the way that we think of the derivative of cosecant. Okay, so moving on to the next portion, we have our trigonometric rules of differentiation. So this is just a review. If I have cosine and I need its derivative, it's negative sine. The derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant times cotangent. Another thing I like to notice here is that the derivatives for secant and cosecant both have those functions in their derivatives. So that's pretty nice. I will say numbers 4 and 5, I never ever remember. Once you get to Calc 2, you will use 3, 4, and 5 quite a bit. But again, 4, 5, and 6, I hardly ever, you're not going to use a whole lot. So you don't really have to memorize it, but I would say just to know what they are and know how to find them when you need to. But 1, 2, and 3 are the ones you will use all the time. So part of the reason that we derive these is so that if you ever get confused and you forget that I made this video or what have you, you know how to find these on your own. You just turn them into the sines and cosine equivalents and then take their derivative using the quotient rule, right? So those are our trigonometric rules of differentiation.